All right, I think we are ready to begin. So hello everyone and welcome to today's webinar. Today's webinar is about the musculoskeletal exoskeleton assessment with AnyBody. My name is Christopher Iversen and I work here at AnyBody Technology. And today I'll be the host of this webinar and I'll be assisted by my colleague Björn Ingelund, who is one of our research and development engineers here at AnyBody. And in the AnyBody webcast series, we host different presenters who have worked with the AnyBody modeling system to cover different use cases. And in today's webcast, I would like to introduce you to two speakers. So first of all, we have Urban Daub, who is a senior expert and business segment manager for the medical technology and ergonomics at Fraunhofer IPA. And then we have Mark Tröster, who is the research team lead at the Digital Human Modeling and Ergonomics at the University of Stuttgart. And Urban and Mark will give us insights on the results of a recent modeling study they did within the research project called DigitalExonomics. And here they used the AnyBody modeling system to evaluate the biomechanical effectiveness of existing occupational exoskeletons. And this presentation will start in a few minutes or so. But just before we start, I will just give you a short general introduction and overview of the AnyBody modeling system. If there is any of you who are unfamiliar with the software or musculoskeletal modeling and simulations in general. But first of all, I would like to draw your attention to the control panel, which appears on the right side of your screen. So you're very welcome to submit questions and comments via the questions panel during the presentation, and we will do our best to address all of these questions at the very end of the webinar. And in case we do not get to answer all of your questions, we'll try to do so by email within a reasonable time. So let's begin with having a look at what the AnyBody modeling system actually is. So the software allows you to do musculoskeletal modeling and simulations. As input, it takes motion data as kinematics and forces, and it calculates the internal body loads as joint reaction forces, muscle activity, and metabolic energy. And at the moment, AnyBody is used really in a wide variety of areas and applications. And there is a few examples of this on this slide. So it could be movement analysis, product optimization design, the field of sports optimization, orthopedics and rehabilitation. It could be ergonomics with and without assistive devices, as for example an exoskeleton, but also in the automotive industry. And just to give you an example of how the workflow could look, so it could be you that provide the recorded motion data as input, and then you can use the body models which you or others have built. Most of these body models comes with the AnyBody managed model repository, which we ship along with the software. And then you can provide some kind of environment, which could be a special type of equipment or, for example, an exoskeleton. And you can then use AnyBody to combine these things and solve the muscle recruitment and run the inverse dynamics simulations. And this basically means that we go from motion to calculating the internal body loads and the interaction with the environment in some cases. You can then output the results and use it for some kind of post-processing. This could be, for example, with a finite element tool, but there's also many users who just choose to close this loop completely by doing some kind of design optimization and then run this cycle multiple times. And this actually brings me to the end of the introduction. So I'll hand over the presenter role to Urban instead.
So thank you very much, Christopher. Do you already see my screen?
We do, yes.
So I have to put this away and that. Perfect. That's okay, great. Yeah, well, thank you again. Thank you very much, Christopher. What a pleasure to be here. Thanks a lot for the invitation to you and AnyBody, of course. This is a great webcast that you have built up over the years, and it's an honor for us to speak here. Let me tell you first where Mark and I are coming from, I mean in the professional context, but I will keep that part short. The Fraunhofer Society, you might have heard of it. It is a society for the advancement of applied research in Germany, a publicly owned research organization with 76 institutes spread throughout Germany, each focusing on different fields of applied science. with about 30,000 employees, mainly scientists and engineers, and sometimes even physiotherapists, and with an annual research budget of about 3 billion euro. It is the biggest organization for applied research and development services in Europe. And this is where we are located in Stuttgart, in direct connection to the university campus. Pretty much the whole area here is the campus, the Fraunhofer area in Stuttgart, with different kind of institutes, 4 institutes there, and one of them is the Fraunhofer IPA. It is also a very typical feature of Fraunhofer institutes that they are always linked to universities. So we have a close cooperation here with Stuttgart STech and University Stuttgart Technology Innovation Campus. And Mark, maybe you can tell us a little bit about the IFF research unit of the University of Stuttgart.
Yes, of course. So hello, welcome from my side. Thank you, Urban, for the introduction. And as Urban mentioned, there is a very close collaboration with the University of Stuttgart IFF Institute between the Fraunhofer and Fraunhofer IPA. And what we're doing at IFF in the research unit, Human Technology Interaction, is that compared to the application-oriented research, we are trying to do more basic application-oriented research. In our case, we have set up 2 main topic focuses. So one is physical assistance systems, where we do research for smart body-worn systems to maintain, restore, or increase human mobility. And the second one, which is mainly my focus, is the topic of digital human modeling and ergonomics, where we're working on an ergonomics exoskeleton assessment methodology, and we are visioning for a digital, personalized, and real-time assessment methodology in the future.
Thank you, Mark. So, yeah, let's start into our topic. The background of what we're talking about is actually musculoskeletal disorders and heavy physical work. This is where we come from and what we see as an increasingly important issue in the industry. And the reason for this is quite clear, as the WHO also indicates by saying low back pain is being the single leading cause of disability in 160 countries, which is what I think pretty amazing in a bad way. It is not only a German or European problem, but it's a worldwide problem. And it affects mobility, dexterity, and early retirement from work, which is a permanent problem with a shortage of skilled workers that we have. And so the problem is about to increase because the population growth and aging will increase as well. And if companies ask us to help them with their ergonomic challenges, this is what we do. This is our analysis, usually based on motion capture data that we collect from workers wearing a body-worn inertial sensor-based system. In this case, you can see it here on the right side, the XSense system. It is based on, let's say, it consists of 17 boxes. These, you can see slightly orange boxes below the glove here, for example, and on the upper arm. They are about the size and the weight of matchboxes, and they're placed all over the body. For our ergonomic assessment, we analyze this data according to biomechanical, orthopedic, sports, training, and work science principles. And we compare critical movement sequences and combinations with the etiologies, so the cause of diseases, with the etiologies of the typical most common musculoskeletal disorders at the specific workplace that is analyzed. So, for example, if there's a special like back pain issue they have, we try to understand where is it coming from, where's the what situation do we have to change, and what are the parameters. And this is being a difference between our method and the current pen and pencil risk analysis methods that are commonly used. Of course, you can have digital versions of them, but let's call them still pen and pencil methods, they are all based on a similar pattern of execution, mostly based on a video of a work situation. You look at the times of people being in bad postures in different parts of the body, for example, the trunk, and in the end, you add up all the times, which gives you a value for the posture index. You will do the same for loads and perhaps repetitions, and in the end, you will use a mathematical formula to get an ergonomic risk score. But this is only half of the truth about how the musculoskeletal disorders, where they're coming from. Sometimes it makes a big difference what you did before you lifted a box, for example, or a battery out of an engine compartment, out of a car, in the front of a car. If the mechanic, for example, has been bending forward for minutes to unscrew the battery and then lifts it out of the engine compartment, then the back muscle is already more exhausted. So the risk of back injury is much higher than if he or she lifted the battery with let's say, a fresh back muscle. It is important to understand that the back muscle has two functions. It will generate the force to lift the battery, and the very deep muscle fibers will coordinate the segments of the spine to keep the loads in each segment as low as possible and to reduce the risk of shear forces. And this is an important factor in preventing back injuries. A list of summarized postures times, it will not be able to see the difference between having a break or not, between leaning forward and lifting the battery. And when we say a pause or something like this, I don't mean like doing nothing. It is more like doing something else in the process, just in an upright position, whatever it may be, such as documentation or preparing the next step, because the time it makes that it takes the mechanic to remove the battery, it will be the same. But for the muscle, it is, and its protective function, it can make a huge difference if it has a pause in between bending forward and lifting. So pen and pencil methods still make sense, and of course they are a good tool to have a first understanding of the workplace, but they also have limits in the depth of the analysis and what they can tell you about this. So if we have understood where the etiologies are coming from, we can think about relief concepts. They should all be in the same manner, like starting with technical measures like lifting devices, organizational measures, just like the little break or the pause in a task description between bending forward and lifting, or job rotation is another typical organizational measure, or personal measures like exoskeletons. And yeah, as you might have expected, there has been a lot of research in the field of exoskeleton in recent years. This can be seen as a reflection of the societal interest in this type of systems. Even if the curve flattens out in 2023, when the increase stops for the first time, there's still a lot of interest in exoskeletons. You can also see in the curve the timeline of when some of the exoskeleton companies launched and their first exoskeletons. So this is a still ongoing process, and we are currently seeing more than 100 commercially available exoskeletons on the market. Yeah, and this is our research fields. Well, this is what we do in terms of exoskeletons at Fraunhofer IPA and University of Stuttgart, IFF. So we do ergonomic and biomechanical requirement analysis in the field and in the lab with our Exsense systems or with other kind of systems. It always depends on the question. We do conceptual and evaluation, conceptualization and evaluation with digital human exoskeleton models. We will hear about this soon more. Of course, we do design or development of passive, semi-active, and active exoskeletons, and we can evaluate these then again in the lab with human in-the-loop experiments. Right. So to keep an overview of these 100 exoskeletons on the market, you can see on this slide our activities. For example, we are organizing the Vericon, an international exoskeleton conference that is every 2 years on the A+A fair in Düsseldorf, and it's the biggest safety and health fair worldwide, every 2 years in Düsseldorf, and we have a congress there named Vericon Europe, and of course the Vericon in the United States. We are participating there as well, and we work in clinical guidelines. For example, here for the use of exoskeletons in an occupational context for primary, secondary, and tertiary prevention of work-associated musculoskeletal disorders. So it's always interesting to understand if you already have chronic back pains, what kind of exoskeletons make sense, and how should they be introduced, and what you have to have in mind with the people that already have back pains. And we work in standardization committees such as the German DIN and the International Standardization Committee of ASTM International, which will soon publish a standardized study design for the evaluation of exoskeletons under lab conditions, but with high relevance for industrial use. And this study format is called the Exoworkathlon. And I will tell you a little bit more about this Exoworkathlon, about this study design. It is a prospective study approach to assess occupational exoskeletons. It creates short work scenarios, the so-called parcours. I will show you soon for the next slide. And they have it's parcours or scenarios with exoskeletal potential, with applying industry and the OSHA, of course. It compares intra-individually, like on the same person, 1 hour work with exoskeleton versus 1 hour without exoskeleton. And the used exoskeletons are named, but there's no data output per exoskeleton device, but only comparative data of work with versus without exoskeleton. So we just want to see, is there a difference that you can see by wearing exoskeletons? And our parcours, you can see in this slide, like the box handling parcours, like very logistic oriented parcours, or sack handling, because we have seen not everybody has boxes. Many companies also handle sacks, and this is although they have the same weight, there's a big difference in handling of box and sacks, of course. And the car assembly parcours, welding parcours, we have power drilling, like these are all for the upper extremities. We have food picking parcours and beam handling, 2 guys, 1 beam. And so here you can see our some key facts about the Exoworkathlon. So far we have already 125 test persons included on 6 different parcours with different exoskeletons. You can see the brand names or the brand logos there, and it already showed significant reduction of subjective stress, significant reduction of muscle activity in corresponding muscles. So mostly it's the back muscles, it's the shoulder muscles. Significant reduction of metabolic stress during welding, and this also leads to a significant improvement in the welding quality, because if you have less stress on the muscle and on the metabolics, you can hold the welding device longer in a let's say in a good position, and this leads to a increase of the welding seam and the travel speed. It is more like it stays the same over the time. You don't get faster because your arms are getting heavy, you stay at the same speed. And it also showed on the left graph, you can see so this quality in the indicators showed an increase of 10%. And you can see on this side the effort of the task without exoskeletons on the different kinds of parcours that are already included, and you see everywhere like a pretty obvious change that happened by using all those different kinds of exoskeleton. Yes, and now I want to hand over to you, Mark. Please tell us a little bit more about the digital ergonomic side.
Thank you very much for the embedding and introduction, Urban. So as Urban mentioned, we are doing ergonomics always within the top principle, and therefore we are gathering a lot of data, and we see a huge potential in methods in the field of digital ergonomics. That means the application of digital human models to get more evidence and to systematize ergonomic measures within a workplace. Therefore, I brought like an overview how digital human modeling works. Like, you have a lot of input data from the environment, anthropometrics, the structure and the manipulation. And of course, in the environment, I would like to highlight there, you could also consider exoskeletons, but you should always consider it holistically within the whole work environment. And with all this input data, you can do all kinds of analysis, fatigue, motion, posture, load, or stress analysis, and so on. And therefore, we brought like 2 examples. We also applied in the mentioned research projects. The first approach you can see on the next slide is like applying the EMA Work Designer, which is a digital work planning tools to do holistic ergonomic work design. That means exoskeletons could be a solution, but you should always ask yourself, are there maybe other solutions? So technology is the answer, but what was the question? And within those holistic tools, you can consider all kinds of ergonomic measures. So you could restructure the workplace, you could use a forklifter, a robot, or maybe you could just redesign how the process will look like. And further now, if you have decided to use an exoskeleton, you can of course use for the biomechanical evaluation musculoskeletal modeling, and therefore we are mainly using the AnyBody modeling system, where you could very precisely have a look on the interesting muscle groups. As example here, the erector spine, like the extending back muscles, and you can see here in comparison with and without an exoskeleton. So as already mentioned, we applied those modeling methods in the research project DigitalExonomics. Open, if you should be, yeah, here we are. So and within this research project, we had like a renowned consortium consisting out of project partners and associated partners, where we were also closely working together with AnyBody technology, where we aimed for a digital work design and ergonomics assessment for the use of occupational exoskeletons. So for this presentation, I would like to outline mainly the modeling methods we were applying in the lab study. You should see on the next slide, or maybe it's a little bit interrupted. Yeah, here we are. So what did we do as main part of the lab study? We applied the mentioned 2 modeling methods. That means we designed in advance with the EMA Work Designer 2 use cases, a shoulder use case and a back use case. That means we could very in detail with relevant stakeholders design the workplaces specifically adapted to anthropometrics and to a realistic motion sequences which are really occurring in reality. Then we measured 17 test persons. We had the opportunity to include also 5 real workers from external partners, and gathered all the in detailed motion data with a motion capture system, in this case Qualisys, and then applied the motion data and the relevant load data to the AnyBody modeling system, wherein we modeled different exoskeletons we were comparing and could use them to set up a comparison and to demonstrate the holistic ergonomic evaluation methods we're aiming for. So why the AnyBody modeling system? To evaluate occupational exoskeletons, mainly because you can have a look on so-called intended biomechanical effects. If you go to the, yeah, we have a little bit of delay. No problem. Yeah, the so-called intended effects for back exoskeletons. Therefore, we brought exemplary results for one test subject. On the left side, you see the maximal compression force in the lumbar joint L4, L5. And you see the comparison of different weight conditions of lifting a box, as you can see in the videos, for different weights of boxes. And we outline different areas of different evaluation areas based on recommended stress limits from the Dortmund guideline of gender and age-specific values. So here you see here you see the leveling based on the applied and modeled test subject. That means what we want to show is like that it's very crucial that you consider kind of in detail the age and gender specifics and compare the different exoskeletons in their effectiveness. And the AnyBody modeling system offers a tool to do this, to quantitatively assess the effect and compare it within the different conditions. And on the right side, you see like just a different way of visualizing the effect. So we see the reduction of the two exoskeletons for the maximal compression force and for the muscle activation in the erector spinae compared to the no exoskeleton condition. And you can directly see that in some cases you have always a decrease, but you should be really aware of in what kind of condition you apply what kind of exoskeleton. And what further offers the tool of musculoskeletal modeling is our so-called not intended biomechanical effects. And therefore, yeah, if we have the right side here, thank you, Urban, you can have an insight of further body regions in the human body. So I brought here 3 examples. You can have a look on the metabolics, of course, an approximated, simplified representation of the metabolics here based on the Umberger model. You see the same lifting sequence for the different weight conditions and exoskeleton conditions. And further, on the right side, you can have a look on the lower extremities. That means in this case, we would like to show like what happens to the hip and what happens to the knee. And what is also very interesting from our perspective is that you can compare it with different like normal load situations. For example, jogging, climbing stairs, or walking. And the system offers you the opportunity to just level and get a better idea of how effective is the exoskeleton and what really happens to the whole musculoskeletal system if you compare different conditions. So further on the next slide, we would also like show for the same motion sequence that you can also have a look on the biomechanical stress over time. And here we would like to outline the leveling of the muscle activation of the erector spinae for the 2 conditions in the model scenario without and with exoskeleton. And you see that at the beginning, of course, you have a strong decrease, but in the end, sometimes you could also have a minor increase in the biomechanical stress, but on a different level of biomechanical of general stress the body can take. So therefore the system offers also a good quantification to get an idea what really happens to the muscles on different levels of activation. And further we developed a holistic evaluation of muscle activities and joint kinetics, and therefore we developed the so-called biomechanical body map for back and shoulder exoskeletons. I would like to outline here the back exoskeletons biomechanical body map. It's just a summary of relevant muscles we think should be considered if you apply a back exoskeleton in a specific motion sequence to really get an idea of what happens to intended biomechanical body regions and what happens to not intended muscle groups and body regions. So as mentioned, the system offers you an opportunity to have a holistic look on muscle activities and also joint kinetics. And therefore we developed a biomechanical body map for the joint kinetics and summed up just relevant joint kinetic parameters from our perspective, which should be considered if you evaluate back exoskeletons in specific motion sequences. Maybe I would like to highlight, for example, for the glenohumeral joint, that means the shoulder joint, the big shoulder joint, the system also offers you the opportunity to have a look on a stability indicator, which means you don't only check like the compression, that means how strong your humerus is pressed into the shoulder, but you can also get an idea of whether there is occurring a specific shearing or something like that. And the stability indicator in our case is dividing the compression through the shearing, and so it gives us an insight of how stable the shoulder stays if you apply, for example, a shoulder exoskeleton. And further important is that in the dynamic motion, you should have a look on the mean and the max values of those forces. And in static motions, it's enough if you check the mean forces. So what did we do in the project? We summed up, we listed those kind of parameters, and those gave us the opportunity to compare like the three conditions here, exemplary for the same test subject for 36 trials. And now you get a tool to really holistically check the intended and not intended biomechanical effects. And of course, what I would like to outline is that the system also offers you the way to include those kind of threshold values. So the color codes directly show you, okay, maybe in what kind of body region you should have a look. You should look more in detail and check what really happens to the musculoskeletal system. So to sum up, we are aiming, and we think that digital human modeling tools offer great opportunity to do digital ergonomic exoskeleton evaluation within the whole top principle, understood within the basic ergonomic principles. And therefore, we are looking for a digital ergonomic exoskeleton score based on the shown biomechanical heat map to evaluate ergonomic measures holistically, but of course specifically exoskeletons. For exoskeletons, from our point of view, there are already existing evaluation methods which could be applied, for example, in the EMA work designer, as we tried out in the research project, and you see effects. But as Urban already mentioned, you can have a much deeper look into the whole musculoskeletal system and better understand what really happens if you apply an ergonomic measure, for example, an exoskeleton, to really see what happens in detail to the musculoskeletal system. So, so to sum up for my part, so what we are working on to develop this digital ergonomic exoskeleton evaluation method to support the ergonomic adoption of occupational exoskeleton. We're currently working on the validation and verification procedure for musculoskeletal models to develop mentioned evaluation method to be applied in digital work planning tools as, for example, the EMA Work Designer. And we would like to demonstrate this on the introduced Exoworkathlon parcours. That means we're aiming for a consensus, and we're very open for exchange on a practical and scientifically credible assessment method for occupational exoskeletons.
So I will have also a last slide. Thank you very much, Mark. A short wrap up about digital ergonomic tools. First thing to mention is ergonomics is important, and it is increasingly important. And the better the physical stress on the musculoskeletal system is understood, the better ergonomic measures can be derived, and they're also like more accepted. Digital tools can tools like musculoskeletal modeling can help to better understand the physical stress, and to improve user friendliness. Sophisticated biomechanical investigations can increasingly be integrated into planning software tools. Well, digital tools can be used to evaluate ergonomic measures in advance before they are implemented in real work. Means you can test it out on a digital way before you like buy all the machines and try it out and figure out that it actually doesn't work. So it could be a much cheaper way to first do a simulated study with those planning tools, and you can also get information about the ergonomics, and they are getting more sophisticated by using musculoskeletal modeling tools. The topic field is complex. We work in various committees in order to be in dialogue with all stakeholders, as many as possible. And of course, we are looking forward to networking with you and on your challenges. So we want to thank you very much. And the last slide, it should show, how you could contact us. We would be happy to discuss, but also I think there's a little time if you have questions right now. Thank you very much.
Thank you very much, Urban and Mark. I will just make myself the presenter and say a few words before we go to the Q&A session. There we go. So I'll just like to say a few words about our online resources and where you can find more information about using the AnyBody modeling system. So if you want to know more about AnyBody technology, then you can go and check out our website, anybodytech.com, where you can find different events, special dates, and also all of our previous webcasts. You can also check out our community website called anyscript.org, and this is really a page for people using AnyBody. So here you can find multiple resources as our wiki page, several blog posts, and links to our repository sites. It's also worth mentioning that it's here our forum is located, so you can go and ask questions and get help from some fellow AnyBody users or some of the engineers who are employed here at AnyBody Technology. And then I would like to highlight another webcast that's coming up shortly. So it's actually the second webcast in this series from the DigitalExonomics project, and it's called Capture It to AnyBody and EMA to AnyBody. So Capture is a motion capture system based on markerless motion capture, and we show the process of using markerless motion capture and getting it into AnyBody. And then, as Mark and already mentioned, this EMA software, how this works together with AnyBody as well. And the registration for this webcast is already available on our website. And then if anyone happens to be attending the Danish Society of Biomechanics on November 22nd, then please stop by our booth there and let's have a talk about musculoskeletal simulations. And to end this, I would like to mention that we maintain a publication list of papers using the AnyBody modeling system on our website, so it's publicly available for everyone. And this list recently reached 1,100 publications, and you can filter it based on industry, research area, and body parts. So it's really a good place to go and search for inspiration if you want to know what have been done already or which groups are interested in which areas. There's also a webcast library where you can find previous webcasts, and I'll also upload the recording of this one there within a couple of days. With that, I would like to thank you for your attention so far, and I think we should take a few questions from the audience.